Well, the next type of transformations that I want to talk about is as follows. We start now with the function g again, which is x minus 1. And again, our function f, the mountain function. And our goal is to compute the composite f of g of x. Again, diagrammatically, what do we get? Well, for each input x that you choose, we find g acting on it, giving us x minus 1, and in turn, our f function acts on this thing, giving us 1 minus x minus 1 squared. Is it okay so far? So, let's draw now the graph of each one of these pieces of the machine. So for the first one, what do we get? Well, can you see? When x is equal to 0, the image is minus 1, so 0 minus 1 must be a point in this graph. When x is equal to 1, 1 minus 1 is 0, so the image of 1 is 0, so the point 1, 0 must be a point on this graph. Well, but because I know from this function form that this thing is a line, well, 2 points determine a line, and so the line is like this. So the function goes like this. So far so good. Again, our mountain function with our zeros at minus 1 and 1. And here again, the top of the mountain at 1. So minus 1, 1, and this is 1. And now let's see. We could now feed again x values on the machine, compute the images, and we have order pairs, x and y's, like so, and you can draw the graph again. But instead, I'm going to do just like previous transformation, and instead feed into this machine the set of points and see what happens to that set of points. So from, for example, let me choose from 1 to 1f. 1f is 3 f's. Let me draw it. So 1 is here, up to here, which is about 3 f's. Can you see? 3 f's is 1.5. When g acts on this set here, well, it subtracts minus 1 for each one of the points in this set. And from the graph, you can immediately see the image. Well, the 1 is mapped into what? 1 minus 1 is 0. So this 1 is mapped into this thing, open. And 3f's, well, 3f's minus 1 is 1f. So this value here, open, is 1f. Well, of course, the intermediate points here are mapped into these points here. So the image of this thing is from 0 to 1f on the vertical axis here, which in turn, now f is going to act on each one of these inputs in the red set. So let me draw it from 0 to 1f. So 1f is here, open, 0 is here, open, and this is the set of points. On each one of those, now f acts, giving us this arc here. Open, you open, can you see? So each one of these axes is transformed into this thing here. Okay? So, this is now the key moment, because our goal, we did this with a single goal in mind. We want to understand what the graph of this thing looks like. And for that, I'm understanding the pieces together, so the G and the F maps. And now I'm going to see how this set is going to, which is mapped into this thing, what does it mean? Well, because this function here attaches elements of this set between 1 and 3f's into these outputs which I draw here. Okay? This set of values. I hope you can see this thing. Let me just write specifically what are the set of points here. So, when it's 0, you see, when it's 0, we have 1 minus 0, which is 1. So we have to exclude the 1, the top of the mountain. And then we have 1f. 1 minus 1f squared is 1 minus 1/4, which gives us 3/4. So this thing is 3/4. So let me draw it specifically. This is 3/4. And this is rule 1. So the set that I'm talking about lives on the vertical axis, and it is this set. Or you should say, is this set of points. Maybe it's easier for you to visualize is being this set of heights. What should we say? The set of y's along this arc. It's probably easier to see than this thing. Okay? So again, our composite function attaches those axes living here into those axes living here, in this arc. So let's make a picture of this thing. What is this set here? It goes from 1, open, up to 3f's, which is about 1.5 here. So the starting, the first part of the order pairs, again, I want to stress this again. We want to pair this with this, the first entries of the order pair and the second entries of the order pair. I just shown here what are the first entries. What are the second entries? Well, the second entries are all the y's in this arc. So when you are going to graph these order pairs, we should draw above this axis the y's on this arc. But that means that you're going to shift this thing into here. So let me draw this carefully, like so. So it's open, goes like this, like so. So to this point is going to map into this point, and so on. Can you see? This is very important. We did not discover yet what the graph of this thing looks like, but you can see from this piece alone what should happen. Because when you compare the part, this is part of this graph, when you compare this part of this graph with the original one, the thing just shifts. Okay? It shifts by how much? Well, it shifts by 1. So because this is the starting point here, which is 0, now it's 1. This is 1f, now it's 3f's. Let me just show it here. 3f's, which is 1.5. Okay? This is how wide is this set? Well, it's 0.5. How wide is this set? Is 0.5. Okay? The transformation from this axis into this axis by the g function, well, is just subtract 1. Okay? By the way, I'd said it the other way around. It's from this to this. So when you subtract minus 1 from this axis, you get this one. Okay? Like so. This is what g does. And that's it. If you understand now for this piece, you can now immediately deduce what would happen for each segment of this function. Because now each segment, you see, is going to be shifted 1 unit to the right. And so let me draw the remaining of the graph like so. It's going to be something like this. Of course, it's going to 0 because this point now is mapped into this thing. Everything shifts. I hope now that you see by this, by thinking about mapping sets, small sets. I chose this one. You could choose any set. But choosing how to see how the sets are mapped, what is the images of these sets, you can see much easier what happens in these kind of transformations. So in conclusion, if you have a function and you decide to subtract from the x something, for example, in this case you subtracted 1, The consequence of this is to shift the graph not to the left but to the right, okay, by 1 unit. And the reason, well, you can run the argument like so, okay, through this thing. Now, I'm gonna now to show you a small video again, showing running these ideas again, which hopefully will complement this thing. So let's see.